The next section is residual analysis. In this video, we're going to look at residual analysis for the purpose of validating model assumptions. We can do residual analysis for detecting outliers and influential observations. That will be the next section. And here, we're going to look at the model assumptions. So residual is the actual y value minus the predicted y value. So that is also the regression error, and we call it residual. And we can plot the residuals to see whether the assumptions for regression analysis are reasonable or not. So given the regression model, the assumptions are about the error term. So the error term is the residual. So we have 4 assumptions. Okay, the expected value of the residuals is equal to 0. The variance of error term remains constant for all values of x, and the e's are independent, and the e's follow normal distribution. We can prepare 4 different plots. 3 of them are about the residuals. So plot number 1, residuals on the y-axis and the independent variable x on the x-axis. The second plot is again residuals on the y-axis, the predicted value y hat on the x-axis. Now this plot, the second plot, turns out to be the same as the first one in the case of simple regression. In multiple regression it will be different, but for in this chapter the first and the second plot, they pretty much are the same. Third one is standardized residuals. So you take the residuals and divide by the standard error. That will give you standardized residual plot, and we can use this to test the assumption of normality. Then there is the fourth plot, which is just simply a normal probability plot, which is a second way of checking for normal distribution. So let's look at what these plots will look like if the assumptions are valid. So the first plot, residual on the y-axis and x on the x-axis. Then if the residuals plot kind of random pattern and about the same width for all different values of x, then that would indicate that the assumptions are valid. So this is a good pattern, a random pattern that has pretty much the same width for all the different values of x. Now, on the other hand, if it is random, but the width of the residuals, if it expands or contracts, so if it changes over different values of x, then the variance is constant for all values of x is probably not valid. So this is one pattern that you should look for. Is it random and the same width all across x, or does the width change over the values of x? Then there is another pattern that you should look for, and that is the width is about the same, but there is a clear pattern among the residuals. So, if this is the pattern that you see when you plot the residuals against x-axis, then this would indicate there is a model problem. So it is the model of linear model, the straight line function is probably not true. You have to bring in non-linear terms in the model. Now the second plot is pretty much the same as the first plot, as I already mentioned in the case of simple regression. Now the third plot is you take the residual and you divide by the standard error of residual. And the standard error or standard deviation of residual is given by s times square root of 1 minus h sub I, where h sub I is given by this formula. Now when we run regression analysis and data analysis, Excel automatically generates the standardized residual. So we don't have to make all these computations. We'll get the value of standardized residuals automatically. Then we can plot that, and if the normal assumption is true, then you would see almost all the standardized residuals to fall within -2 to +2. So approximately about 95% of the standardized residuals. If not, then normal distribution assumption needs to be checked out. Okay. There is another way of checking for normality, and that is a normal probability plot. And this normal probability plot should, the points on the normal probability plot should fall along a straight line. If that is so, then normal probability assumption is all right. And again, this plot is also automatically generated by data analysis command.